Okay, so let's just dive right in. I want you to imagine a future maybe, I don't know, 5 or 10 years away.
Uh-huh.
And in this future, the words lifelong treatment are just gone from the medical vocabulary, especially for things like lupus, MS, rheumatoid arthritis.
It sounds like pure science fiction.
It really does.
Yeah.
But the sources we've been digging into, all the latest research, it suggests that this era isn't coming. It's actually, well, it's starting now.
It's a complete paradigm shift, which is what's so fascinating. For decades, the entire strategy for autoimmune disease was just suppression.
Right, just camping down the symptoms.
Exactly. Your immune system is firing on your own body, what doctors call friendly fire, and the only tool you have is to try and extinguish that fire whenever it flares up.
Which locks patients into this awful cycle, right? Lifelong, really expensive meds, serious side effects.
And it's not even a guarantee. The disease can still flare up and cause incredible damage.
Because you're never fixing the root cause.
Never. You're just managing the crisis. You're not rebooting the system or fixing that fundamental programming error.
So that's our mission for this deep dive. We're going to unpack this revolutionary idea of reprogramming the immune system at a cellular level.
Using technologies that were, originally built to fight cancer.
It's a huge leap. I think Dr. Maximilian Koenig at Johns Hopkins put it best. He said, we're entering a new era with a chance to control the disease in ways we've never seen before.
And that control, it's coming from something called CAR-T therapy. That's chimeric antigen receptor T-cell therapy.
A bit of a mouthful.
It is, yeah. But it was developed to go after really hard-to-treat blood cancers, like leukemia and lymphoma.
So what was that light bulb moment? The connection between a cancer therapy and, say, arthritis?
It was actually an incredibly elegant insight. It turns out the cells that go haywire in those blood cancers, they're called B cells, are the exact same type of cell that misbehaves in a lot of autoimmune diseases.
The very same cells.
The very same. They're the little factories producing the rogue antibodies that attack your own body. So the thinking was, well, if we have a tool that can destroy cancerous B cells...
Why not use it to destroy the autoimmune B cells? That makes perfect sense.
Sure.
Okay, let's walk you through this process because it is intensely personal.
Yeah.
We're talking about reprogramming a person's own cells.
It's a monumental process. It starts by filtering T cells. Think of them as the immune system's soldiers right out of the patient's blood.
And those get sent off to a special lab.
Correct. And in that lab, they're genetically engineered. They're given a new receptor, this chimeric antigen receptor, which basically gives them one super specific mission.
Seek and destroy their B-cell relatives.
Exactly. But that's not the end of it. Before those modified cells, these living drugs, are put back in, the patient has to go through a round of chemo.
Whoa, wait. Chemotherapy. That sounds incredibly intense. Why wipe out parts of the immune system just to add new cells in?
You have to clear the field. It's like preparing soil before you plant new seeds. The chemo makes space for the millions of new reprogrammed T cells to multiply and really take hold. It ensures the body is ready for that reboot.
It's a huge undertaking. But the results, the early human results are just staggering.
They are. After some promising studies in mice, a team in Germany, led by Dr. George Schett, started human trials. Their first patient was a young woman with severe lupus. She'd failed every other treatment.
And what happened?
A single infusion, that's it. And since March of 2021, she has been in complete deep remission. No other medications.
Since 2021, that's not just managing symptoms.
No, it's a total cellular reset. And his team has gone on to treat dozens more patients with other conditions, myositis, scleroderma, with very, very few relapses so far.
When you hear stories like that, you start to believe it. This really is a new era.
And when you hear from the patients themselves, it just drives it home.
Oh, absolutely. The story of Milady Gonzalez, a 35-year-old in New York, diagnosed with lupus at 24, and the disease just ravaged her body.
It attacked her lungs, her kidneys.
She said it got so bad she could barely walk, couldn't even lift her 3-year-old son. Just completely devastating.
So when her doctors at NYU Langone suggested this experimental therapy, adapted from oncology, what a leap of faith that is.
An incredible leap. But the result, within months, the pain started to fade, her strength came back, and now she's living without pain, without pills. She said she can run and catch up with my child.
Wow.
She forgot what it was like to just be herself. That's the real measure here, isn't it? Restoring a life.
It is. And you see that same hope in the story of Ellie Rubin, 60, from Florida. She battled lupus for 3 decades. It even attacked her spinal cord.
Terrifying.
Yeah. She only became eligible for CAR T because she also developed lymphoma, so she got the treatment for the cancer.
And what happened to the lupus?
She's now 2 years out, and there are no signs of either. No cancer and no lupus. She talked about this one moment where it just hit her, oh my God, I don't feel sick anymore.
That's the goal. But we do need to bring in some caution here. These stories are amazing, but this is not a simple process.
Not at all. It's intense, it's complex, and, it's incredibly expensive right now. A similar commercial CAR T treatment for cancer can run you upwards of $300,000 or $400,000.
That is a staggering number. And it raises the question, is this a technology that's, well, is it only for the wealthy right now? Is that cost just because it's so new and customized?
It's mostly the customization and scale, but that barrier is very real. And beyond the price, we still have big questions. How safe is it in the long term? How long does this immune reboot really last?
Right.
But even with all those questions, it is, without a doubt, the most advanced method being tested anywhere in the world.
So that brings us to the next logical step. If the current CAR T is so personalized and expensive, people must be working on ways to make it cheaper and more accessible.
Absolutely. The field is just exploding with alternatives.
Yeah.
Some companies are already testing what you could call ready-made versions of CAR T.
Ready-made, so not using the patient's own cells.
Exactly. The idea is to use cells from healthy, universal donors. This would cut down the wait time from weeks to, almost immediately. It's the first step toward an off-the-shelf treatment.
Okay, but what about approaches that don't involve destroying cells at all? Something less aggressive.
That's one of the most exciting areas. It involves what some call peacemaker cells. The scientific name is regulatory T cells, or RTREGs.
Peacemaker cells, I like that.
They're basically the immune system's natural brakes. Their job is to tell the other, more aggressive cells to stand down.
So instead of programming T cells to attack, you'd program these RTREGs to just calm everything down, to suppress the bad actors.
Precisely. It's a non-destructive approach. You're trying to restore balance, not, scorch the earth. That's a much better strategy for certain conditions, like type 1 diabetes, where you need that delicate touch.
I also read about something called T-cell engagers. How are they different from CAR T?
They're much less personalized. A T-cell engager is basically a lab-made antibody that acts like a biological matchmaker. You inject it, and it has 2 arms.
Okay.
One arm grabs onto a bad B cell. The other arm grabs onto one of your existing T cells, one that's just floating by. It physically connects them.
So it brings the weapon directly to the target without having to reprogram anything.
Yes. It just redirects the army you already have. And now we're even seeing attempts at hyper-precision. That's what Dr. Koenig's lab is working on. They want to get beyond killing all B cells.
They want to target just the bad ones. How do you even tell them apart?
They're looking for what they call biological barcodes. Rogue B cells have slightly different identifiers on their surface, so the goal is to create an engager that only tags those specific bad cells for destruction.
And it would leave the healthy B cells alone.
Right, so your body can still fight off the flu or a cold. It's like cellular surgery.
And then there's the approach that feels the most futuristic of all, using mRNA. We all know it from the COVID vaccines, but a lab run by Jordan Green is using it to reprogram the immune system.
Yeah, his team is all about delivery. They pack the mRNA instructions into these tiny biodegradable nanoparticles. It's like sending a message in a microscopic bottle.
A message with instructions for the immune system's generals.
Right, and the instructions have 2 parts. First, stop the bad, attacking T cells.
That's the second part.
Multiply the good guys.
Yeah.
The instructions also tell the system to pump out more of those peacemaker regulatory T cells.
So it's not just about stopping the attack, it's about building up a new, healthy defense force.
Exactly. The hope is those peacemaker cells will divide, and create an entire army of healthy cells. They've already had success using it in mice to target the specific cells involved in type 1 diabetes. It's incredibly promising.
So if we can get that precise, can we shift from treatment to actual prevention? Can we stop the disease before it even starts?
That's the holy grail. And we're already seeing the first steps with type 1 diabetes. Dr. Kevin Dean at the University of Colorado points out that we can already test for it, see it forming in the blood long before a person has any symptoms.
And there's already a drug, right?
Yeah.
Tocilizumab.
Exactly. It's already approved, and it can delay the onset of symptoms for years. It works by modulating those early rogue cells and protecting insulin production for as long as possible.
It buys people time.
It buys them years. And now Dr. Dean is trying to do the same thing for rheumatoid arthritis.
That seems much harder. How do you find someone who's going to get RA years from now?
It's like finding a needle in a haystack, but they're finding it. A big U.S. study tracked people who carry a specific antibody that puts them at high risk for RA.
Okay.
And they found they could map distinct immune system changes happening a full 7 years before the first swollen joint ever appeared.
7 years. That's a massive window of opportunity to intervene.
It's an unprecedented window. Those changes they mapped are now the targets for future preventative drugs. He's leading a big new study called Stop RA to find more people in that high-risk group and figure out how to stop the disease before it ever takes hold.
This whole deep dive,
Yeah.
it really shows that the next decade is going to look completely different. We're moving from just managing a chronic illness to talking about actual cures and now even prevention.
It's a massive shift.
So before we wrap up, we should probably ground this in some practical advice.
Yeah.
What should you be doing right now?
The most critical thing is, if you are on medication, do not stop your treatment, please. This is all very exciting, but it's still largely experimental. You have to work with your doctor to manage your condition today.
Absolutely. But you be proactive. Start keeping really detailed records, symptoms, side effects, everything. That information is gold for your doctor, and it's essential if you ever decide to look into a clinical trial.
And if autoimmune disease runs in your family, think about genetic testing. It can flag risks you didn't even know you had. And then there's the basics: good nutrition, managing stress, exercise. Building a healthier you provides the best possible foundation for any treatment.
In the end, all this research is about hope. One of our sources put it perfectly.
Yeah.
We are witnessing the birth of a new medicine.
Yeah, and Dr. Koenig is convinced the next 10 years will forever and dramatically change our field. The feeling is that these treatments, which are now only in special clinics, could be the standard of care in just 5 or 10 years.
So we want to leave you with this provocative thought, and it comes straight from the scientists doing this work. The generation of our children, they might look back and wonder why anyone ever had to take immunosuppressants for their entire lives.
That's the future we're building. A world where that just sounds, well, ancient.